Hello everyone. It's time to make some bugs happen. It is officially that time of the day in which I sit down in front of a computer and I just write some bullshit and somehow it all works. Don't ask me how. I have no idea. Uh, Also, I feel like very small on this. I don't know what's happening. There. I'm just gonna do the entire stream like this. So I look a little bit taller. Or like this. My legs are killing me right now. Alright. What am I even doing today? I believe it's data deserialization. Binary data deserialization. Yes. Which again, as I said yesterday, is getting me this close. This close. They're slightly apart to doing reflection in C. Don't underestimate my ability to do macros. Alright. So, what am I talking about? Actually, new here is a perfect inspiration for what I want to do. It's a shell that works with structured data. And it can display it in tables or in little... I guess they also count this as a table. I would count this more as like a single entry into a table. So I want my terminal for my operating system to be able to display something like this. In order to do that, I am overcomplicating things, as you always should not do, but as I always do. I have an application that already does this kind of. I mean, that should be getting to do this, where you can talk to /environment/display, and you can use it to tell the terminal from the process that you're trying to run. You can tell the terminal what type of information you're going to be sending it. Where you can send raw data, as in text data. Probably will need to rename this one to just text. Can I do it? I think I can do it, because the only place where I've used this value before is... Oh yeah, it's actually 2 places, it seems. 4 places, okay. Please ignore this. Text with an X. Alright, that's all of them. That's all of them. So you can make your terminal display data in a text form, like a normal terminal, in a table similar to this thing, and in a document similar to this thing. That's what I'm going for. On Friday and the 2 days before, so last Monday and last Sunday, I built the entire /environment thing. To do that, I built a virtual file system for each process. Because really, /environment just redirects you to /environments/your process ID. / whatever else comes after. But after struggling with that a lot, I don't know why it was so difficult. Eventually I got it to work. So you write to /environment/display, you tell it what type of data you want. Then, of course, in order to do something like this, you don't only tell it, okay, I want you to display the data in a table, but you also tell it what that table should look like. So I set up a system for serializing binary data, which is what I'm going to continue doing today, because I worked on serializing data. Now I need to deserialize the data, actually read it. And the way that works is you talk to a file called, if I'm not mistaken, this should be here. data structure. And there you send it what this is supposed to look like, what each header is supposed to look like, what the structure of the data is going to look like. He's adjusting. He's awake. He's sleeping on a pillow. He is punching the pillow. He is stabbing the pillow. And he is... Brother, what are you doing to the pillow? Don't do... Okay, we're gonna stop looking at him. Jester, you have to embarrass me every single time. I swear to God. Unbelievable guy. Is this what I pay you for? Alright, seems to have settled. A pillow is only his, so I don't really have a... And the entire bed is only his, so I don't really have a problem with this, but still, ew. But yeah, you have to tell your terminal... Going from the dog doing that to this. You're going for, you tell the terminal what the data is going to look like, and then that way, with that information, the terminal will be able to interpret raw data that you send it, parse it, and show it in a table or in a document view like this one. By the way, I like what New has done here, and this is kind of what I'm going to build at first, because there's an entire rabbit hole to go down when it comes to rendering these things. And I haven't yet decided how I want to do it, because this is technically text. This is literally text. The borders of the table are literally text. I don't know if I want to do a TUI, a ratatouille, or if I just want to do a normal UI. I don't know yet, so I'm gonna take the time between today's stream and Friday's stream to decide that. But yeah, for the time being, it's just gonna be structured data, but just text without the little borders around it. But I would like to also have a better way of displaying this. Like, this is very I don't know, very plain, very uninspired. I feel like you can definitely come up with some better UI than this. If we're gonna do this, might as well try to play around with it a little bit. But before I can do any of this, I do need to have a data deserialization. And after that, I should be able to plug all the things together and have the program tell the terminal, this is what the data is going to look like, this is the data, and the terminal can render it, again, into a very simplified version of this thing. Hello, MX. Would I ever consider a midweek stream? Sometimes, but it depends on how much time I have. And yeah, I removed the on-screen chat. Also, I just found out that Discord just got rid of its Your Lucky Day manual updates by porting over their Rust-based automatic update. Really? I did notice I haven't gotten that shit in a while. I was actually gonna say that when you used to open Discord on Mac or Windows, it would just auto-update. So you would open it and then it would tell you downloading update 1 of 36, and it would take forever. But you didn't have to do anything besides wait. On Linux though, it would tell you, it's your lucky day. You don't get to use Discord for a while, because it would tell you that there's an update. That would download an installer through your browser. So it would open your browser if you didn't have it open. It would download an installer. You had to run the installer. You had to give it your admin password, because software requires root privilege in Linux for whatever reason. And that wouldn't actually install the update. It would install the updater. At which point, you would open Discord again. It wouldn't even auto-open for you. You had to open it again, and this time it would show you the installing update thing. I did kind of notice that this didn't happen. The thing is that I had Discord open, and I noticed the little icon that they have for when there's an update. and I clicked it, thinking it was gonna take me to download the installer, but instead it just auto updated in right there. And what I thought was, if you have Discord open, it just skips the downloading installer part. But if you don't, it requires you to download an installer. But no, apparently they just patched it. This is from May 4th. I'm not so sure. Maybe the thing that I noticed happened before that. But anyway, very nice. We come through the latest changes. Okay, we received and fixed a good amount of user reports of small but pesky issues in server administrator flows. Networking stack for Android video delivery. And yet video is still limited to like 10 megabytes, which is like literally nothing. You can't do anything with 10 megabytes of video. By the way, Discord, just FYI. But they use this emoji, so they're relatable. Bye Nitro. Organizational improvements. Soundboard data when you join a voice chat. Okay, are you a Linux user? Finally, I found the one I'm looking for. Are you sick of that lovely fuck off. That lovely modal we made to tell you that there's an update you need to go manually install? If so, boy, do I have good news for you. We've ported a Rust-based updater to... Oh my god. I understand that this is like a Discord engineering post for people who are more tech savvy, but bragging about it being Rust-based is so funny. We've ported our updater to Linux. By the way, it's Rust. I use Rust, by the way. Allowing Linux to update itself like on Windows and Mac. Then again, if you're on Mac, you're not using Linux, unless you're me. In which case, you're slowly going insane. We've ported a Rust-based updater to Linux, allowing Linux to update itself like on Windows. Additionally, we now support RPM and PKG tar package formats for installation. Cool. Wait, PKG tar is for Arch packages? Interesting. You know, I briefly considered switching to Arch, but I'm not doing that. No. No, not doing that. Not doing that shit. The background for the godlike and beyond godlike messages in the escalating copy username are no longer transparent. I don't know what this is about. I'm just gonna stop reading this. The patch note that I wanted is this one. So again, they're saying, well, to be fair, this was written on May 4th, but the update may have come out before that. And I don't remember when it is that I noticed that I wasn't downloading new installers. So, yeah. Nice. PKG is a package, tar is a tar, and ZST is compression. I know tars are not compressed, but aren't they already a package? Isn't tar also a package? A tape archive file is widely used... Hold on, forgot. Not supposed to be talking to you. A file format and a file archiver program. Combines multiple files into a single archive file in the tar file format. And then POSIX abandoned tar in favor of PAX. Really? I've never heard of PAX, I think. What extension does it use? Oh, it still uses tar. Wait, no, they replaced the utility. Not the format, but the utility. Okay. So tar is a package, but so is PKG. Although I don't think PKG is a single format. Just anyone uses that for packaging. I don't know about that. Well, I don't know why I'm going to use PKG format. See, macOS and iOS use PKG, which uses XAR. PlayStation, just PlayStation, all right, uses it for all this stuff. System V, I still don't know if I'm supposed to read it as System V or System. Well, to be fair, I was talking about RISC. I just got confused. This is Unix. PKG files are CPIO archives that contain specific file tree structures. Symbian uses PKG. See, so this is different than this, which is probably different than this, but we don't have any information on that. Symbian uses PKG files to store configuration information used to generate sys installer packages. Okay, sys. BOS uses PKG as part of their software packaging platform. So pretty much everyone uses PKG. Apple Newton operating, so holy shit, we're going far. Used files ending in PKG for Newton applications and software. They do not share their file format as the macOS one. PTC uses zip. Microsoft is set to use PKG for profile storage on Xbox Network. Do we really not know? Well, on Xbox Network, that's server side. So, okay. And the L3 avionics systems use some PKG files for software updates. So yeah, it's pretty much just any extension, but it's not a specific format. But it's supposed to be for a package. Then tar is also a package. And then, yeah, the ZST is compression. So that's interesting. Why am I not seeing this? Oh, okay, because it's up here. I'm still not super used to vertical tabs, but I'm liking them. I switched to them on my laptop too. So, yeah. I'm used to them at this point, but I'm not as used to them as I was with the, 100 years or so that I was using horizontal tabs. Okay, back to packaging, to the packaging that I'm doing, which is data serialization and deserialization. And I'm gonna use this for, again, right now I'm gonna use it for the terminal. I also plan on using it for my game engine. I plan on using the shit out of it for my game engine, to be completely honest. And it might power a reflection system in my programming language, which I keep saying whenever I get back to it, but honestly, starting to be time to get back to my compiler because terminal scripting is gonna need to be a thing soon, and I'm gonna need a parser and an interpreter for that. And I already have a compiler architecture. I have a compiler ecosystem. I want it to be kind of configurable so you can build it to compile different languages and build it to, again, compile or interpret. So I might just use the same, it would make sense to use the same existing infrastructure to do terminal scripting. Alright, I completely forgot what this is. Wait, there's another thing that I completely remembered just now, but I mentioned in my Discord server about Apple. I haven't even committed the changes. But I was stress testing my game engine on my laptop earlier. And without me actually making any changes to any of the code or pulling any changes, my code wasn't compiling anymore. And it turns out it's because I updated my toolchain, which happens pretty much every time you open Xcode, especially when you don't use it that often, which is the case right now. And it turns out that Apple has replaced a lot of these memory functions, memset, memcopy, memmem, And those. They replaced them with their own memory safe versions, it turns out. And the way that they did it is kind of annoying because I'm not using any Apple built-in any Apple specific headers or anything like that, but I do use this types.h, and this types.h has, the definitions for stuff like int32 or i32, all of these things, including well, those are the definitions for my system. But when you compile this for cross-platform, these types can get really annoying. For example, the size of a size t is different depending on the platform. I have it as an oh my god, as an unsigned long int. Apple requires it to be an unsigned long long. Linux wants it to be an unsigned long int, and so does Windows, I believe. One of them is different. So for simplicity, I just include the header that defines it, and that saves me a lot of headaches. But it turns out that Apple updated a header that header includes in their platform and overrode all of these functions with essentially just a define. Something like that. I don't remember if they were hard coding a last argument or something, but essentially what this does is just you call memset, but you are actually calling memset check. They did that for memset because this modifies memory, memcopy, and memmem. No, not memmem, because this is just reading memory, so I think it was just memset and memcopy. But I added a define, an undefine actually, to something else. Maybe it wasn't necessary. I just did it proactively. Yeah. Oh, memmove. Memmove is another one. So I had to undefine these. Not nudef, undef memset. So you can then redefine them here. Now, since I technically had to do this, notice this. Let the record show that libc is fucking stupid. Why is libc fucking stupid? Because memset takes a void destination where you're going to set the memory, how much memory you're going to set, and what byte value you're going to set it to. But the size of the variable is an integer, 32 bits, not 1 byte, but 4. Back when this function was created, it probably was 1 byte, so it made sense. But nowadays, that's no longer the case. And nobody bothered updating it to be something like char. So I kinda need to do this. But since I'm already doing this for Mac now, I think I might be able to do this. And it's so much clearer. Because if I'm not mistaken, on yesterday's stream I actually made a mistake where I was using memset to set a 32-bit value. We can actually check. And might as well start opening the files that I'm going to be working with. So here or here. I guess not. Or maybe it was just some test code that I ended up deleting. Yeah, might be that. Or it was printf. I don't remember. But anyway, I think yesterday or the day before, I was using memset, and I forgot about the fact that it takes an 8-bit value, and I was passing it a 32-bit value, and some data was being lost. So the replacement for that is to call memset32, which is a custom function that I made that specifically takes a 32-bit value. And Yeah, it is so much cleaner. Honestly, we don't need a remake of C, we just need a remake of libc. The problem is, technically, I could just... Where's the types.h? I could just do the work, right, and do the definitions properly. Or even, they wouldn't really be necessary if it wasn't for the fact that on cross-platform, I do have dependencies besides this. I have glfw, and glfw depends on OpenGL as well. And it doesn't. My project depends on OpenGL to use it with glfw. And I either make a completely standalone, no dependencies cross-platform solution, or I have to do this shit. I have to still rely on these kind of quirks of libc. Now, personally, I would go for the first one, but we have to be realistic, unfortunately. As much as actually I'm struggling so much with getting a window of the right size on Mac, because glfw, like Windows on Mac, the window, like window, requires a little bit of extra configuration because Mac has like physical and virtual pixel sizes, so the frame buffer is actually like twice as big as the actual window because of like retina displays and like different resolutions and whatnot. So the Apple API for making a window does give you the correct configuration options to make it work well, but glfw doesn't really expose them, and so kind of difficult to get a window of the correct size that I'm expecting on Mac. Now, Raylib was doing it because Raylib is doing some extra hacky stuff, which I might have to do as well. I guess we'll see. The problem is, of course, my cross-platform framework is becoming bigger if I add all these dependencies instead of just using glfw for it. But I guess we'll see. Hello, Nita. Rust for systems programming, I don't think is a good idea. Rust expects a bunch of memory safety features that are incompatible with making a system. I mean, if you're doing something like a compiler, which is also a system, or a game engine or something like that, I'm sure Rust would be great. But yeah, Rust kind of assumes that userland exists. Let's put it that way. So it assumes that some level of memory safety is already provided, and the operating system is responsible for providing that. So by definition, everything that the operating system does is direct memory, talking directly to memory, not through a safe channel, because it provides the safe channel. So while the operating system is starting up, it has to talk to memory directly.
What do you think about the new programming language Rust?
Well, that, mostly. It makes it kind of annoying to work with if you have to constantly ask for permission to do everything on Rust. Which is why, like, whenever I see operating system code for Rust, I'm just like, there's no need for this. It's mostly boilerplate. For userland, I understand it. For other systems that are operating systems, I understand it. For anything that is built on an existing operating system, or an existing kernel at the very least, I think probably good idea. Horrible syntax. I hate the syntax as well. But even some other memory safe languages, like this shit that Apple is doing. By the way, I need to remove this before I shoot myself in the foot with it. And this. Nah, I gotta undo all these changes. Yeah, I personally don't like Rust, but on top of that, there's that. For low-level systems programming, I don't think it's a good idea. For higher-level systems programming, probably, yes. Okay, so data serialization. Essentially, if you want to serialize some data, you tell the serializer what that data is going to look like, which is this, which if you think about it, is just a very ugly, very verbose version of defining a struct. By the way, I haven't bothered dealing with alignment probably properly. So for now, you have to pass a packed struct. I'll probably remove this limitation if I have time during the week. It's essentially just doing a little bit of extra math that if the structure is aligned, and for example, you're reading a Boolean value, then there's probably going to be padding. Or if you're working with values of different sizes, they're going to be aligned to a correct address, so you just have to move to that correct address. It shouldn't be too difficult, but I just haven't bothered with it. Actually, if I finish the deserialization quickly enough today, and I've been yapping for 37 minutes without writing a single line of code, but if I do that, I might be able to maybe look into it. We might look into packed attributes. Although I think I will have to tell the system whether the structure is packed or not. But anyway, the way that the system works is, yes, you do this structure definition, you pass it to the serializer, which is actually capable of serializing this as well, because we will need to send this to the terminal as well. Like I said, we're sending this or this, and then we're sending the raw data. So we have to tell it what the data is going to look like. So we serialize this, pass it over to the application. It can deserialize it. This part is already written. And then this is testing what the serialized data looks like. We can write it to here. Right now, this file doesn't even exist, so this will fail. But yeah, the terminal will eventually, this file will exist and the terminal will be listening to it. And then we have some data. We can serialize it as well using this definition. This is what the data looks like, which is part of the structure. And we can serialize it into data that gets printed here. Now, what we also need to do is deserialize it. Yes, the language is C. And followed your Raspberry Pi Linux driver video. Nice. Welcome. Raspberry Pi was... Wait, Linux driver? Oh, okay. Because I did talk about installing Linux, but I didn't do anything with Linux in the end. Just testing that my Raspberry Pi worked. The thing is that, when I first tried writing an operating system back in the 1970s, I got a Raspberry Pi. Hell, you know what? This bitch right here. The Raspberry Pi Zero. And I was having so much trouble working with it. I couldn't even make an LED blink or do anything properly. And then years later, I needed a Raspberry Pi, and I was like, oh, I still have that old Raspberry Pi that I used for that thing that never worked out. So I tried installing Linux on it, and it kept failing in the most ridiculous ways, and it turns out that the Raspberry Pi was defective. So I learned my lesson, and now, before I even try to install my own operating system on the damn thing, I'm going to start off with a system that I already know that works, which is their own distribution of Linux. Why do I still have this thing? It's completely defective. It doesn't even work. Oh well. A little bit of history. Redacted OS version 1. The failed version. Okay. So we have environment data structure. Actually, from the point of view of this application, we're already done. We're telling the terminal what the data is going to look like. We're telling the terminal what the data is. We just haven't... First off, the terminal is not listening. We're just speaking to a brick wall right now. And also, even if the terminal was listening, it cannot understand anything because it cannot deserialize the data. But I wrote the deserialization of the data structure. So the logic is going to be similar. The main difference is when you deserialize the data structure, you already know what the data structure is going to look like. It always looks like this. It's always an integer followed by a string. Whereas I have to kind of generalize this code a little bit more to be able to deserialize data based on the data structure. It started to remind me of Huffman trees when I did compression, because with Huffman trees, you have to decompress a tree that you can then use to decompress the image that you're trying to decompress. Well, the data. So it's starting to remind me of that. You have to first deserialize the data structure, and then you have to use that to deserialize the data. Able to display a picture of my cat on the Raspberry Pi 3B. It boots on the 3B, actually. The thing is that the 3B has like weird interrupts. It just doesn't use the same interrupt system as the rest of the Raspberry Pi, as newer Raspberry Pis. But honestly, I probably should try to get it to work on the Pi 3B because it's the one that's closest to working. I don't need to do PCIe drivers for it. And PCIe drivers have genuinely scared me away from writing driver code. I just don't want to do it. And it's not even that bad, it's just like there's very little documentation, very little stuff to go off. Despite PCIe being so widespread, pretty much every x86 motherboard has it. But yeah, apparently you don't see a whole lot of information on it. Or I haven't found a whole lot of information on it. Or specifically on the way that the Raspberry Pi's one works. So yeah, haven't been able to get it to work. I still want to know what that glitch at the top of the screen is. It's been there for months. Anyway, data deserialisation. We have a binary serializer, or at least we hope to. And that serializer holds the data that we want to use to have the structure. Twitch video weird. What do you mean? Please don't tell me you're struggling with 4K video again. That looks fine to me. Alright, let me know if it looks, yeah, it looks good to me. And now I'm watching myself. Anyway, yeah, the binary serializer already holds the data structure that we're trying to deserialize. So really all we need to do is go through it while there is data, which there's a condition here that I'll figure out in a second. I need to get back into writing this code, but if I'm not mistaken, where is it? Define structure. Okay, I called it that. Okay. Yeah, I'm using a while true here as well. Alright, so that's good. Okay, so we're going to do this for as long as we have data in our binary file. And we're just going to go through it. We could have multiple parts of data at the same time. Like we can have, when you're working with a table, you have, this is the structure, you have multiple entries, which look like this. But you want to parse them one at a time. Field count tells you how many there are. In this case, there are 5. In the case that I'm testing, there also are 5. Hello, goldfish. And you're going to complain about signage. I am starting to really regret using unsigned. Technically, unsigned makes a lot of sense for a lot of things. Like size is an unsigned value because you can't have a negative size. The problem with that is, if you're doing like math on a size, you could get a negative result if, for example, it's a wrong size of some sort. But you can't just do if size is less than 0, because that will never be true. Instead, you have to check if size is bigger than the biggest valid value that it can have. It's really weird. Or you can cast it to a negative, I guess. Yeah, but it's a pain in the ass. And I'm starting to regret using unsigned in so many places, especially because it complains if I use an int here, because that is signed. This is an unsigned count, and so, yeah, it complains about that. Hello, QJR. Alright, so we're going to go through all our data until we run out of it. we're going to go through field by field, so trying to deserialize a field at a time. And I feel like putting this in a buffer, but I'm not entirely sure. Yeah, I'm gonna use a buffer for this. Literally buffers I created so that I could do whatever I need. With data of any kind. So a buffer is an automatically growing section of data. Although I think in this case it will actually shrink, not grow. So we probably won't need to. Yeah. Best case scenario, I'm gonna bet on this. Right, we have a binary data, and the binary data could almost be copied directly into the field that we're trying to deserialize, except for strings. Strings are the only place where we can't really do that, because strings don't go directly in the field. Instead, usually you have some sort of pointer to them. Right, so we'll need to deserialize strings separately. And also for serializing strings, it's the same thing. Serializing data, you just copy it. Serializing data that isn't a string, you just copy it. I don't have arrays or anything like that right now, so yeah. Serializing strings requires you to first put the length of the string, then the actual string. So, a little bit weird. I'm also reserving 4 bytes so that eventually I can store the strings encoding once I have more complex strings. Because, if I do end up doing a TUI with this stuff, these don't fit in 8 bits. Guaranteed. Doesn't work like that. I think. I'm good, by the way, QJR. How are you? Alright, so we're going to go through our fields step by step, and serializer structure I is going to be the struct def field. There's no need to do that, to be honest. It's just going to be the field that we're trying to read from. That field has a type, and that type has a size, which tells us how much data we're supposed to read. Now, how much did I define for a string? I defined it as the size of a string. I don't know about that one, brother. It's the size of a string slice. I'm using strings to store information, but it should be a string slice, not a string. Although... Where's the deserializer for the structure again? I need to look at that real quick. Gets the name from here by scanning a string. Okay, no, I think we're good. Okay. So I created a function for getting the next bit of data, which can be a string, or it can be I32, or it can be something else. But I don't believe I made a generic version. I did, in the sense that all of these are just a macro that works the same way, but I didn't make a version that we can call generically. So I'm going to do that. And that's probably going to make serialization particularly fast and easy to do. Oh. Almost. Okay. Yeah, I can do it. Bin scan size. All right. Where is this type being used? Okay, it's used as an output value here. Okay, so I have to think about that a little bit. I'm just going to delete this definition. I'm going to write code, and then I'm going to figure out what the name of the function is going to be. So we're going to have a bin scan size, and that's going to take, instead of a type, it's going to take a size. And that, no. Let me instead do this. Bin scan size is going to, instead of specifying, this is a simple check to see if there's enough data to scan the size that we're expecting. Now this needs to be made into a void pointer. That's already a pointer. This needs to be made into a memcpy, where we're trying to write into the output value from a, again, void pointer of this using the memcpy, no, not the memcpy, the size that we're passed in. All right, so that should generalize the function except for this part. Bin scan size, and it's not even a macro. It's just that. Get rid of these. And size t, size. Alright, so I did this wrong because, well, yeah, I did it wrong. And we're going to need to include a memcpy.h, no, memory / memory.h. Alright, so that works. And now I can simplify these functions to be return a bin scan size call using the scanner that we're given, using the size of the type, and using the out value, which will get cast to a void pointer. All right, so this is what the final function is going to look like. So the definition was correct, but I needed to check. Okay. So I think with this, we should be able to kind of scan an arbitrary amount of data. Semi-arbitrary, because really it's defined by data structures. But this tells us the size of the field that we're trying to read. This tells us the name of the field that we're trying to read. And then we should be able to bin scan. Oh, bin scan size. I didn't see you there. All right, bin scan size. Taking a binary scanner that I haven't created. So let me do that. Right, so this binary scanner is again just doing some very simple bounds checking on our data using the data's data and data length. Since data is considered to be a string, should be a sized pointer, to be honest. But a size pointer and a string kind of look the same internally. So that's just pointer and size. and I changed the signature. This is why I removed the signature from the other function. I'm not sure why I made this use, well, U8 because it's byte-sized data. Yes, if that's okay. All right. Okay, so you're gonna scan using the scanner, and you're going to pass the size, and you're gonna write that into a probably temporary buffer. Can I create a temporary buffer like this? Yes. And this function is hard-coded to return one of these values, so it won't be a particularly big buffer. All right, so you're gonna write it into this buffer. I just realized I created two buffers. And also, if I use the buffer type, it would save me a lot of work. Okay, so I don't feel like replacing all of them, so I'm gonna do it, but I'm just gonna create an alternate version of it. All right, so we're gonna create a version of U that uses a buffer instead of a void out value. Scan size buff, that's correct. Using a buffer called buff. If no buffer or no buff buffer or buff cursor or buff options is read-only, or, well, that's really all the checks we can do right now. So I can replace this memcopy call with a buffer write limit. You're going to write into the buffer. Where are you going to write from? The scanner data plus scanner cursor. The size is going to be this size right here. And this is going to return how many bytes it wrote. And if that is not equal to size, we're going to return false because that failed somehow. Then we're going to increase the cursor and everything's going to be fine. All right, so I don't feel like replacing all of the calls, but I should, because using a buffer makes it a lot easier for me to do this stuff. But I'll do it in a minute. Right now we can scan directly into this buffer, and that is going to give us the data that we want to read. Hello, Gauri. That can fail, right? And if that fails, then we didn't read data that we were expecting to read. There's two possibilities here. We fail to read the first field, which means we're done reading data. Or we didn't fail to read. Well, we can do a better check, which is that if the scanner reached the end, if the scanner cursor is bigger or equal than the scanner size, then we're done reading data. We want to break out of these two loops, and we're going to want to return I need to think about this even more. Do I want to serialize it directly into the type, or do I want to serialize it into a dictionary? I can serialize it into raw data, in which case I just return a buffer. No. Alright, I need to think about this. There's two kinds of deserialization here that we can do. One, where we just put it into raw data, and it turns into as if we were populating a struct, so it turns into something like this. And another one where we also keep the names of the values that we're serializing, and we serialize it into a dictionary. They're kind of separate. What I need right now is to serialize into a dictionary. So I'm going to do that one. All right. So in this situation, we're done reading data. And otherwise, we failed, and failing is easy. We just return 0, and the dictionary that we're going to be working with to store data into it's not a dictionary. It is supposed to be an array of dictionaries. Damn. So we're working with more than one data. Anyway. Damn it. Now I need to think about that as well. But anyway, here we're supposed to destroy the return data because we're not returning anything. There was an error. Failed to read field. We can even print which field failed. That would be field.name. And that's it. We just return nothing. But again, what we actually have here is an array of dictionaries. Lord. All right. Give me a minute to think about it while there's an ad running. I'll be right back. Alright, add is over. And here's the interesting thing when it comes to deserializing data. You can deserialize it as just raw data. Right? You get binary data, binary data. Or, which is what I want right now, but it isn't always what I want to deserialize the data in a more structured manner into a dictionary, essentially, because that allows me to build tables and build these things out of it. Now, is that really the best thing that I can do when it comes to deserializing data? Like even to displaying data like this, and I'm deserializing it as I'm receiving it into structures. Can I not then use the same structure that I used to deserialize it to also display the data? So essentially use this same function. Okay, I know how to structure what I want. Although it's not the best, but yeah, this works like that. Okay. I can use a function pointer to define how I want to interpret the data that I'm reading. And I can return a boolean. Then I can store that however I want. Here I return true. This is the situation in which we've run out of data to read. Here I can return false with also an error message, and I don't have to destroy any data. That's on you. On read. Right, so little deserialization with a function pointer. Ain't that amazing? Right, so any deserializer that wants to read data into raw data can just put it in this buffer. I don't need the buffer anymore, actually. Nice, like that. Alright, so I don't need this buffer anymore. I can store the data temporarily in this buffer right here. Then, if I'm unable to scan, then I know whether or not we succeeded, return true. Or if we didn't, we failed to read a field that we were expecting to read. Oh well, sucks to be you. Return false. Otherwise, we call the callback, which is on read. We pass it the field and a sized pointer with our buffer and the size. Now, it is a temporary buffer. Ah, you want the pointer to that. Is this a pointer? Does that count? That should be correct, right? Yeah, because otherwise I'm returning the address of this thing on the stack. It is a temporary pointer, so if you don't store it or you don't use it immediately when you get this callback, it will get destroyed or corrupted. But that's on you what you want to do with that data. Now, there is a tiny issue with that. I'm not handling strings. Strings are an entirely different can of worms because we have allocated data sometimes. No, sorry. That goes there. Alright, so this works. This very simple serialization will work when we don't have a string. But if the field type equals to binary type string, and in the future might be able to support arrays with the same system and whatnot, we're going to have to do something a little bit more complex. Yes, this is on GitHub. Should be able to run this to get it. Alright, it's not too difficult in the sense that we know that we're going to be receiving a string from oh, no. Bin scan string. Alright, we're going to be creating a string, right? String str. Empty is fine. Alright, so we're going to be scanning a string like this into this. And if that fails, then the exact same thing that happens here. But if it doesn't fail, then we got data. We can tell you the string data and string length, which is kind of the equivalent to a string slice. Like I said, I made strings size pointer and string slice. They're kind of the same concept, just string is a specialized pointer. Maybe alloct set this to true and set this to false. And the reason for that is that the string is already being allocated. What we're passing you here, the pointer itself, the slice, is just a reference to the string. But we're telling you, by the way, we've allocated some memory for this. Whereas in these cases, all we're doing is telling you exactly how much we read and what that information is. So you can then interpret it as whatever you want to read it. So here I need to add is alloced. How do you spell that? Alloced? Allocated. Alright, there we go. Allocated. Let's skip the issues. Alright. So this deserializer should be able to either print structured data or store it in a raw binary format, or display it in some other way. Let's test it. Again, I'm still not going to plug it into the terminal. I'm going to do that later. But, alright, the data gets serialized here. It got put into this buffer. It then got sent to the file that, again, right now is failing because that file doesn't even exist. It prints the data. And then we're going to want to call bin ser deserialize using our binary serializer, using the I don't have a helper for this, so I'm going to make one real quick. Static inline sized pointer, sized ptr from buffer, takes a buffer buff, and return pretty much the same thing. Again, string slices and pointers are same thing. They just changed their names a little bit. And the pointer is an actual pointer, so you have to convert it to a U pointer. But it's the same data, essentially, just casted differently. Right, but for the sake of simplicity, sized pointer from buffer, and we pass it the buffer. And then read the ser data. That's going to be the name of the function that I use to do the read, which I'm going to have to create real quick. It's going to be a void. It's going to take a struct definition for the field. It is going to take a sized pointer for the data, and it is going to take a isAlloc. I'm fine with not calling it allocated. Because if it is allocated, we're going to want a free. But before that, we're going to want to print the field name, and we're going to want to print, let's make this, try to structure it a little bit. Ah, wait, how do we print the data? We don't know the type that it is. It is a custom allocator, yes. Interesting. I'm going to change the structure up a little bit. Then I'm going to mess with this a little bit too. It depends on the... I can make a printer for it, right? Shouldn't be like something like this, but just print. Like to string. Need to think about it a little bit more. The data is a pointer. The pointer to a type. The type we get from here. But we don't know what that type is. So let me just build it here and then move it wherever I need to move it. Wait, print data. Again, with a struct definition, field, and a size pointer data. I'm gonna make it just very verbose. Switch field type. Populate that. If it's invalid, we're gonna break. I will do that later. I can probably put it in a macro. I know there's generic, but that's a newer feature that I do not have access to. For these, it's all the same. For this, it's this. For this, it's also that. And for this, it's this, where you pass actually data directly to it. This is a string slice. And again, like I said, a size pointer and a string slice look the same. So this is for an I16. This is for an I32. Sure, you could write this better if it was a Monday evening. Nah, cannot be bothered right now. See, I almost forgot the breaks. Alright, so just print data field data, and then release the data if necessary. Cool. Why am I running new? I don't have a standard library, and yes, that's pretty much it. Well, I have my own library, and a bunch of comments in it saying that libc is stupid, so mostly that. It crashed. The terminal doesn't know it yet. It crashed on data test line 1. I highly doubt you crashed on line 1. Well, it crashed on 0. So we should probably check. Yes, it's a customized. What is bare metal iOS? Am I reading that right? I'm assuming it's not los with a lowercase l and, well, I don't know. Wait, no, I am reading it wrong. Bare metal OS. I read it as bare metal iOS. So, yeah, okay. Never mind, got it. See why I'm saying this code is shit right now, but it is Monday evening? Because I can't even read a fucking word right. So, don't exactly know where it is crashing because it's claiming to be crashing at address 0, but that's not really accurate. Can you give us a memory dump? Because that address, well, points to memory 118. So I can see where that is. On a mem copy. Okay. The buffer is the only place doing a mem copy, I believe, because I was doing a mem copy, but then I removed it. Alright, so let's make this a little bit more printable. Deserializing field, and you're gonna tell me the name of it. Thank you very much. Do that. Deserializing field, and then the my bad. I do speak Spanish. Alright, deserializing field number, so it crashes on the very first one. Amazing. Thank you for that. Alright, so it's not this. Alright, so you get the size here. You create a buffer here. You should be creating a buffer of the correct size, as far as I know. Gracias. Then this function is again the one that everything else is relying on, and we are getting valid serialized data. So it wouldn't work if this function wasn't working. It is checking that the scanner size can fit the data and outputting that to the out value with the size that we were given and advancing the cursor. I don't really see what a problem is here. But yeah, you're trying to write to the stack, which is correct because the buffer is currently in the stack. That's fine. No, wait. This is the stack pointer. This is the address that we're writing to. It's 1. Okay, so reading x into x. Reading size into buff. So you never know when I'm doing buffers like that if I'm supposed to be using a ampersand or not. But it claims to be reading 4 bytes of data into this address here, ED70, which is close enough to this one to make me think that it's okay. The stack is smaller, which is why this address is smaller, because it allocated 4 bytes for the buffer. I think we should be fine with that. And it's not printing the full address because it's a 64-bit address. I'm only printing 32 bits here. So, yeah, that is 4 and 4. Yes. And yeah, what's failing is a mem copy. Weird. But it is worth checking which value I'm writing to. Because again, I may be passing it wrong. I'm not. I'm not passing it wrong. That is the correct address. You're supposed to write to that address. And then, again, we're calling a mem copy, which doesn't go into the unaligned block, just goes into, doesn't even go into this block, goes into this block. You should not be going into this block. This is for reading unaligned memory. When you're reading unaligned memory, oh, you could be reading unaligned memory, to be fair. Wait, hold on. Translation fault level 2. Okay, so there's a little bit more information to that. It can tell me whether it was when reading or writing. Reading from memory. Okay, so the address that's failing isn't... and just to be fair, translation fault level 2. Okay, yes. Okay, so I was debugging the destination address when I should be checking the source address. That is apparently set to 0 for some reason. Oh, I know exactly why. I just need to remember which one of these files. This one. Right, scanner data plus scanner... No, okay, never mind. I thought it was because I was doing... Is the scanner data invalid and I just didn't notice? Let me see. I'm high feeling that's what's happening because it's trying to read from address 1. But it's still crashing, so no. And it's the exact same crash. So also no. It's 64-bit. I love that the terminal is so slow that it's still printing before it even gets to the actual error. Anyway, reading from FF7F D390. Which is the address of... Am I passing it wrong? I'm telling you to deserialize it from the buffer and the buffer size. So I shouldn't be passing it wrong. I'm literally reading it here. But the first value is a 1. Okay, so I kind of starting to understand. Turns out, it's crashing by trying to read from address 1, and the first value is 1. So where I should be passing an address, I'm passing a value. I don't understand where that's happening. Okay, you're deserializing this address into scanner.data, which is a pointer to the value, right? Then you're doing the scan size thing using the scanner data plus the scanner cursor. That should be an address, right? I mean, it clearly isn't if memcopy is failing there, but it is an address, 390. Okay, so I'm telling you to read. I swear to God, I keep dealing with the most ridiculous bugs these days. Where's line 18? It's actually worse than I thought. It said that it was line... Oh no, 118. Okay, this one. Right, when reading from memory, it's failing, which means... Oh, you could be reading either value, to be fair, because you're incrementing them. But again, I can look exactly at which one this is. I used to translate the exception. Oh, you don't do a dump. Oh fuck. I don't want to. Oh, I don't want to use GDB. It's a little bit. That would be very. That would be very weird if that was the cause of the crash. Functions have existed for decades. Not really. Yeah, it's not that. And that actually made it worse. Again, I'm telling memcopy, read from this address into this address and copy there, but somehow it's trying to read from the value, not the address. That doesn't make any sense. But again, it's worked so far. I'm not reading the value here, I'm just casting it to a void, but I'm getting the data and the cursor, which again, you could read the data value of it, and that would be Just to be clear, how are you reading 1? Okay. Okay, so here's what's happening. We have an address that we're calculating here. We're casting it into a void and we're passing it to memcopy. The address is this thing right here. Its value is 1. And memcopy is failing because it cannot read from address 1, which is the value, not the address. What? I don't I don't know. I don't know, man. What is happening? Is there a bug that is only happening? Is there a bug in memcopy that is only happening here? Probably not. Where's the dump? Here. I'm gonna run that also for tools, and if you can for modules as well. Alright, so run make dump. And we can see the crashing address is this one. This is the this instruction, right? We can take it a step further. No, that didn't work before. Okay, so the value of S8 gets put into the value of D8, which is destination byte. Why are we in this loop in the first place? This loop here runs if the destination address or the source address are unaligned. They're not on a byte boundary. They both end in 0, which means they are on a byte boundary. How are we in this address right now? Speechless. I'm speechless right now. That didn't crash. So the crash is not actually happening there. Okay. The evil dwarf is at work again. The debugger is lying about the name of this fucking file. The crash isn't happening on memory 18. No, except the memory value is correct. But I guess then it isn't happening here. It must be happening somewhere after we call this function. So I think the value is correct. Like this is correct. So I guess dwarf isn't lying. Scanned. Okay, yes. Okay, so the bug is happening in here. Jesus Christ. I kind of assumed it was that mem copy, honestly. I realize my mistake now. What's probably crashing is this shit. In the sense that I actually said, I don't remember if I'm supposed to pass the buffer or the address to the buffer. And guess what? I completely forgot about that. I got mind wiped after I said that. After I said, let me keep that in mind. So if this crash happens, that's probably what's causing it. I forgot to do that. And so I was... Yeah, forget about it. It still crashes, so no. But okay. It scans the value. And for that matter, we know that it's crashing, so we should be able to read the value like this. Except that isn't the right value, so buffer is already the address. So that was correct. So the buffer in question that we're receiving is in this address, data size, no, not data size, data pointer. Data is in this address, which is the stack address in which we have the value. And then the data is an I32. Where this is the pointer to that date. Is it the top or the bottom? No, it should be fine. I'm very confused. Is an I32, yes. And then what happens if I just don't do this thing? That's gonna print the pointer, right? It's gonna be minus 4000. Data is in... Now it crashed without printing the type. Is this bug getting worse? This bug is actually getting worse. This is so ridiculous. And of type 4. What is type 4? An I64? Unless, hold on. Oh, okay. I understand. It moved because the bug is fixed here. Yeah, but it doesn't... I am still very confused by all of this. So I made it not crash, and I know that strings already work. This is a pointer, so you cast it to an int pointer. I genuinely don't understand how this is a problem. Alright, deserializing field number. We read 4 bytes into this value. From here, we're reading it correctly. Data is this, and of type 3. The pointer is the same exact pointer that we wrote into. And when we read the data of the pointer, we can't read anything. This is such a confusing bug. I'm probably just doing something weird with memory, but I don't understand why. Or what. This is the data that is inside of the buffer. 1000. So why does printing it as an integer and dereferencing it give me the wrong value? Oh, I'm also using a different, like... Brother, this is making no sense. It's a valid pointer. It has valid data. But dereferencing the valid pointer with valid data is not giving me valid data. Um, I've... You're kidding me. Yeah, I'm seeing the chat. Hey, mention it's Monday evening and I'm tired. How much time did I waste on this bullshit? We're gonna spend the rest of the stream in shameful silence. For the love of God. Oh my God. That is genuinely so dumb. Thank you, by the way. This is so dumb. Combined, we have one brain cell. Yeah. I clearly don't have it right now. I don't know which one of you is using it, but I would like you to give it back. Um... I swear to God, I lose some sanity points every time I get on here and code. That's why I've started saying that we're gonna code some bugs and maybe some programs as well. Am I wrong? Am I wrong? When I start the stream, I've started saying that. Am I wrong? So hold on, let me might as well just try it, since we already know that it works. Just get rid of the prints. And get rid of the prints. Yeah, I would have thought Clang would have caught that actually. Kind of surprising that it doesn't. Great, okay, we did it. Alright, so it's so stupid. The entire time, all that happened is I forgot an argument, and this actually dereferences the value which I was already dereferencing. So that's why it was so. Okay. So, ignoring that, we do have we have other logs right now, and it's not very structured data, but we do have structured data right now in the terminal. It's just that the program is printing it itself. We have number 1, name numero uno, type dir, size 6, modified a while ago. Right. So the deserializer works. Despite my best efforts. Okay. So the deserializer works. And now is the time to move to separate its logic, right, from the application doing its own data serialization and deserialization and displaying the data to the application serializing its data, telling the terminal this is the structure of the data, this is the data, you're going to decode the structure, decode the data, and draw it as I told you to do here. Which we're telling it to do as a document, which is going to look a lot like this. It's not going to look anything more complex than this. Maybe if I have time, I'm going to give these a little color. I do believe I can set color manually in the terminal. I just don't have escape sequences. I used to have escape sequences, and then some code was refactored at some point and they disappeared. They were not accurate escape sequences, they were just hex values, but still. Okay, hell, that was fucking great. Alright, so if I'm not mistaken, the terminal, the program again is already doing everything that it needs to do. It's sending the serialized data, it's sending the serialized data structure, and it's telling the terminal to put itself in document display mode. The terminal now needs to listen to that, and also there needs to be files for that. So the easy part is going to be the files. So all you need to do is define them, I believe. I hope. So process, environment, environment.c. This is where we define the environment's file system module, which defines two new entries, data and data structure. What is up, my guy? Do I give them a data signature? No, this can be raw data, really. There should be a data signature called raw data. Well, it's just raw. And this is a data structure, which I'm actually going to give its own little 8-bit, if I'm not mistaken. I mean, 8 characters. Data structure signature. To be fair, we're not doing a terminal emulation, we're doing a terminal blasphemy. Because, yeah, I'm not doing everything in text. I'm using different files to send different types of data. Though I am still using the main escape sequence used by terminals, but I'm only using it to say, hey, by the way, terminal, I have some new data for you. Otherwise, the terminal doesn't know this. All right, so let me take a quick look through the code of this thing. I do remember there was some display hard coding. For opening files, right. Yeah, I do need to do this part manually. Data structure and data. Depending on the file, we are going to create a buffer for it. Oh, okay, I'm creating a buffer here. Okay. So we are just going to create a buffer for you. Buffer create. And we're going to have to hold these buffers somewhere. So I'll need hash maps for this time for real. All right, your size. All right, so for the data, we're going to allocate what, a page? We're going to allow it to grow. It's going to hold raw data. And we are going to give it env type data. All right, so that's another thing I need to do. Env type structure. Okay, so a different file descriptor. When you open the display file, it holds the 16 bits of the process ID here and 16 bits of the type of file that it is, and just stores it. Then that is just mapping a value of the process directly onto the into a buffer. Here instead we're creating a buffer, and this buffer we have to store somewhere. Something similar to what we're doing here. A data structure probably won't need a full kilobyte, so we can allocate like 256, but it can still grow if it needs more. I create these buffers, and We can actually... Oh, hold on. I already have buffers for them. Oh, never mind then. It's a lot easier. I just copy this code. Instead of the display buffer, this is the data buffer. And the data buffer. No. I create it. Okay, no, never mind. What I had before was good. It's just where I store the buffer changes. Alright. This buffer that I'm creating for you, I'm gonna put it inside of the data buffer. And this buffer that I'm creating for you, I'm gonna put inside the structure buffer. Cool. Then when we try to open the files, that's how we get them. And when we resolve the file descriptor into a buffer, we just take the buffer from there. In case it's an environment type data, we just return that buffer that we just saved. And in case it's an environment type structure, we proc environment structure. Okay, so that should allow for writing to the files and then the terminal can read from the files. I think I've done everything. All right, there's an ad running, so I'll be back in 2 minutes. What the hell? Hold on. Okay, we're good. Thank you, camera, for deciding to not work. All right, so actually look taller like that, so it's fine. Okay, so I just added 2 new files to my environment system module, which will allow the terminal to pick up on this raw data that we're sending it. And then the terminal will need to parse it, will need to show it to us, and we need to do stuff with it. Which is just going to be mostly copying and pasting code. First stuff I need to see though. Okay, I saw before there were some file system errors because those files didn't actually exist. Now they do seem to exist, so I do believe that the terminal is working correctly. Okay, I mean not the terminal, the file system is working correctly. Now I need to make the terminal work. All right, so terminal. About you. So first thing you're gonna do, it says this will eventually not be displayed and a table will be displayed instead. So I'm just gonna clean up that a little bit. Hold on, clean everything up actually. Go into the shared library, not into the serialization. No, not into the shared library either. Into tools, data test here. Alright, so I'm gonna get rid of this because it doesn't make any sense to have it. Instead, there's actually a environment sync function call, which is just the same print that I just removed, but you know, it makes it a little cleaner. If I ever change the way that the synchronizing with the terminal works, well, you don't need to worry about it. It's already there. And first thing I need to make to the terminal. After this point, we've changed the display type of the terminal to document. You shouldn't be displaying normal output anymore. You're still gonna read it because we're using it for command values, for ASCII command values, but you're not going to print it. So first off, gonna get rid of this. It's already not needed. I'm keeping the bell, the silent bell. Okay, I think actually the functionality that I was gonna add is already here. You only display text if we're in text mode. I think the thing is that before I was calling it after, so it didn't work. Okay, this should display in raw text. This displays in raw text because... Oh, because this is not coming from the process. No, wait, why are you printing that? Oh, because this print is coming from the file system, so it is happening before we fully synchronize with the terminal. Alright, so I needed to get rid of that one. Alright, let's try that again. There should be no logs, no information in the terminal whatsoever. And that is correct. Now, terminal, you'll need to open another file. So it's starting to get a little annoying to open files one by one like this. Also, why am I using like string 1, string 2, strings... Well, whatever. Yeah, it works. Data and data structure, which I might just rename to... Let me just do that. Instead of saying that I'm going to do it in the future, let's do it now. Literally 3 changes. That's it. Okay, structure. You're going to open that and you're going to open data. Data file descriptor and the structure structure file descriptor. And you're going to create those. Cool. You're then going to open S4 data into the data file descriptor. What's up, Jester? You're awake. And we're going to free that string. We're going to do the same thing with the 5th string into the structure file descriptor. Thank you for that autocomplete. That was an incredible job you did. All right. Code's starting to get a little bit long, but Can I maybe simplify it a little bit? Are there any other like ASCII escape sequences that I can use? I mean ASCII commands that I can use to tell it to synchronize different things? Because I probably will need them, so. There is the start of heading. Although, what the hell is that? Um, Essentially, I wanted to stream the data because as you get new data, you parse more of it. But I also wanted to, which I might need to make the deserializer work kind of asynchronously. But I'll see about that. I need to have a way of telling it, hey, the data structure changed. So I need to use one of these for that. And I don't think it can be any of these. Well, what is form feed? Page break. Oh, so no, not that one. Most likely just gonna be character 1. Yeah, start of heading works because it kind of telling you I'm changing the data structure of what I'm sending you. There's some weird searches in the autocomplete on that one. SOH, the start of heading character was originally designed for use in telecommunications like teleprinters and teletypewriters to indicate the beginning of a sequence of characters that form a machine-readable address or routing information. Okay, so that's not exactly what I'm using it for, but I am using it to tell you the beginning of a transmission. So yes, 1 works for that. So, very similar thing to what you're doing here with, if the character is this, which I do believe is literally value 1, yes, then you're going to read not from the display, but from the structure. You're going to read from the structure into a buffer that I'm going to give you. It's going to be a little bit more complex than this. So, all right. First off, if you don't have a valid file descriptor for the file that you're supposed to be reading from, then we just set everything to text. Otherwise, we don't do this. Wait. Otherwise, we do whatever goes in here, which is going to be a little bit more complex than this. What is your problem? Inequality comparison. Oh. Got rid of that. All right. I'll handle the actual read. Well, no, I can do it. I can do it easily with read full file. The entire reason for doing this is that I can do it with read full file. I can read the entire file of environment. Hold on, then that changes things a little bit. I need the string, but I don't need to open the file. All right. So read full file of string 5. I do want the size of that, so I'll put it here. Read full file is, I believe, a helper. So files helpers. All right, we're good. Okay, so you're going to read that into a buffer. So that already reads the entire file for us, and then we should be able to call with the correct import data serialize serial. Bin serial define structure. That is exactly right. We're going to need to create a serializer, which we can do here. Empty by default. All right, so we create a serializer, and you are going to take its structure and its length, and you're going to deserialize that. Which will make our binary deserializer have enough data to deserialize the data that we're trying to read. And again, I should make the binary deserializer kind of capable of, by the way, I need to get rid of this check. And instead replace it with a if no struct size, well, if struct size and struct buffer, then do this thing. Right, so this is going to deserialize the structure of the data that we received from the process. Now, besides that, I'm going to want to use an end of text. This is kind of temporary because I do need to eventually make my... Well, I don't know if it's temporary. I might keep it. I don't know. Essentially to tell the terminal, hey, I just send you more data. It's going to be something very similar to this, but it's going to be data in all of these, your data size. You're going to read it, and you're going to call a binary serializer deserialize using our process serializer. The size pointer that we're going to create for it using the data buffer and data size. Cast this to a U pointer. And now term emit table, term emit data. This is gonna be a pain in the ass because I need to use a C function pointer. Term emit data, which, thank you C++. I have to do the same thing that I'm doing here. Yeah, you're no longer going to be using this or this. Spoiler alert. You don't need these two files at all, actually. And you don't need these two strings at all either. I do think it's going to be, yeah, it is a little bit of overhead because you're going through the file system in both cases. Oh no, wait, I do need the strings, so keep the strings. And because it tells me that one of them is not being used, that means that okay, you're supposed to be 3. End of text. End of text goes to string number 4. I need to give these strings better names. Holy hell. It made sense when it was 2, now it's 5. So I'll take a minute to give them better names in a second. Before that though, we will need to have an identical function to this one, but because C++, you cannot pass C++ pointers to C function pointers, so we'll have to do that ourselves. You will need to know what a structure definition is. To do that, you're going to include data serialize. Can you autocomplete? Thank you. Not binary scanner, binary serializer. There. Alright, so you're going to have a function that looks like this. We are then going to put that function directly under this one, specifically tied to terminal. Field data is allocated. And here, it's going to be a particularly easy function. Because I'm just going to copy this. And if it's allocated, we are supposed to release the data ourselves. All right, and the terminal emit data function, just gonna copy this for it. But with this data, field data and is allocated, field data is allocated, and that's simple. So protect the terminal of your mom. What's the other function that I'm doing the exact same thing for? It's put slice. Ah, so that's not a protected member. That is a public member. Okay. I was wondering why I was complaining about it being protected here, but not the other one, but the other one isn't protected. All right, so essentially the table will give us structured data, allegedly. I'm going to also include environment types, and I'm going to define some of these into types because otherwise, what the hell are you doing? This is environment command display sync. This is environment command struct sync, and this is environment command data sync. So U4 3 are going to be defined as some kind of escaped character. All right, so display sync, we're going to use this one. Well, is there a better one? Start of heading, start of text, end of transfer. I don't need to use the start, I just need to use the end. Because end is when the terminal reads the entire thing. So I do need to use the start of heading to tell it, hey, I'm going to be sending you data. And I'm using the end of text to tell you I'm done. Well, I'm going to be sending you data that looks like this. And then I'm done sending you data, so display it. And this is change the display type. That is what those mean. This is possible, but it is cursed. No, I don't think it is possible, actually. Yeah, I can't really use it in here without doing this kind of stuff. Just very ugly. A chart literal from char literal. Yeah, that's what I want. String literal from char literal. Now you can do it the other way around. I guess it's easier to do string from literal than literal from string. I skipped the wrong part. What the hell are you doing? There. Alright, so you can just print the string version of this. And you can... Oh, what the hell? I told you. Alright, hold on. Define, go up, copy this, put it here, remove the string part, and then the value of that is going to be parenthesis, char pointer of this thing, which we don't even need the parenthesis for. Message passing model, I'm using everything you're passing is a plain function call straight out like the other end of a network. That is kind of how terminals work too, for that matter. Although they are made for yeah, that is the way that I'm treating it. Because at the end of the day, your terminal is a process, and your process is a process. Your command is a process. So the terminal needs to be able to synchronize with it somehow. And this is just the easiest way to do it. First coding stream not using AI. Yeah, you would be surprised. There's some actual... I swear to God, I used to say I didn't know who was out there using AI. That was just because I wasn't watching enough streams. I am now. And I get it. Alright, so wait, I forgot to also create some env display sync, env data sync, which is just a print of the env cmd data sync string. And the last one, which is the structure sync, which uses the structure string. Okay. So environment sync becomes env display sync. Didn't I put this whole thing into a helper? I did, okay. Alright, so you should be able to call switch environment display with just the value of the one that you're trying to do, which is a lot easier to call. Then I should even be able to put these two things into a static inline void set environment structure, which does work with data serialization. Takes fields and a number of them, right? So these fields and this number, and automatically serializes them for you, sends them over the network, and then sends a struct sync call. All right. So now I can just call that function, get rid of this one. I can't really claim to understand why I did this. You shouldn't have to define the structure like this. All right, it's a new signature for you, makes it a lot easier. You can actually just return this thing. You can actually be a static inline. Which now takes the same arguments as this. Okay, so that gives us our serializer. We're then going to send some data. We can get rid of this log. We serialize that data into a buffer, which we can then here we do want to do this part manually, right? But this part we don't have to do manually. Static inline void send environment data, which takes a void pointer to the data and a size t to the size. And using the word buffer, I already use a type for that. So just buff and size, and then on top of that, send an env data sync. And that gives us the function name being send environment data. We send with the buff buffer and the buff buffer size. Serialize data, and at this point, the terminal should already have received it, and we don't need to deserialize it here at all. Am I deserializing it in the terminal? Did I end up finishing the entire functionality of it? If you receive a display sync, you change the display type. If you receive a struct sync, you define the structure for your serializer. If you receive a data sync, you read the data and you deserialize it, and then you term emit data. Yeah, that should be correct. I absolutely don't think that using AI for streaming is entertaining. Now, I have to say, there's so many streams where the entire all that's going on in that stream is just talking about AI. It's not even coding, just talking about it. It's just incessant yapping and saying absolutely nothing. But on top of that, yeah, I don't really see the point of streaming coding when you're just going to be doing it with an AI. Weird that Clank didn't give me an error there. Usually it would. Clank is breaking down more and more, I feel like. Fuck. Every time I write this code, I hate it. Because I hate myself for writing C++, really. Alright, first test of this thing. Well, that didn't work. Alright, first off, let's make sure that the terminal is receiving information. And then just do very similar stuff here, please. Very similar prints. Put one here, one here. Boom. Alright, let me see which one of these. Yeah, I am talking about some streams I have seen that are genuinely just about talking about coding. And I understand it to a certain extent. But if you spend all your time talking about coding, when are you actually coding? Also, if you're talking about AI, you're not even talking about that. So is there genuinely that much information to talk about when it comes to AI? Oh, but this model is 0.001% faster than the other one. Let's talk about it for 3 hours. I don't know. Alright, so we're receiving all the information that we should be receiving, it looks like. And deserialize should be telling us if that worked or not. And also this one also returns a boolean. This one returns a void. Why am I returning a void? Returning a void in most functions feels like a waste of a return. You could inform about whether it succeeded or not. You could give some kind of information. Alright, so I expect it to tell me that it has 5 fields. Z really is the best, yes. I tried a bunch and said it was genuinely the best. Alright, data test. Okay, so neither of them succeeds. Well, obviously this one is gonna fail because you can't deserialize if we don't have enough data. But like, if we don't have enough data, what is happening to you? Where can this fail? Really only here or here? Alright, so fail to read struct type. Which we should, to be fair, like actually be printing errors here. Fail the screen struct name. No, field. Field name. With a break and that. Alright. Failed to read field type. For which field? at scanner cursor. At scanner cursor. All right. So most likely it's not the deserializer itself that's failing. Most likely it's the data itself. At 5A. Okay, so it has read a few. It looks like. I'm getting flashbacks here, but I'm gonna try to do it right. 2 arguments? 2 arguments. Alright. No more hour wasted debugging this shit. Alright, number, name, type, size modified, and then you fail to read field type at 5A. Oh, the file size is bigger. I understand. The size of the file is actually determined by yeah, okay. Like when I'm writing to this thing, I'm writing to a file that has already a certain size, I think 256 characters. I'm using less than that, but because the serializer knows that there's more data than that, then it fails. So I could truncate it, which write should already do, to be honest. Simple write should already be truncating. But who's truncating? Because I do remember I used this function somewhere. I need to see who's doing it. Probably in the... It's a lot of boilerplate. It's too much boilerplate. Nobody's calling truncate. Truncate F? Helpers. Okay, here. Write full file. Okay, so I can use write full file, which automatically truncates. Whereas write... Simple write is a little bit weird because it... What are you writing exactly? It doesn't append or do anything like that. It should append, to be honest. It should append. So yeah, what I want here is full write. Write full file. Or really, sWriteF should have a way of specifying, are you appending or are you... Let me add that real quick. Because it's more efficient than write full file. Because in a way, it's 4 syscalls in one. I'm making it a boolean. I'm probably going to make it into a proper type later on. But anyway, sWriteF is now going to take a new parameter. So in the kernel, sWriteF is going to take a syscall argument type boolean name trunk. No, what did I call it? I called it append. The argument is proc x3, and we don't write to the argument itself. All right, so simple write append. append. That's not a boolean, buddy. It's an actual, okay. Yeah, just. No, what the hell am I writing? There. All right. Now, simple write, append. So, if append, then you want to write to the end of the file, which is seek using the file descriptor that you just opened to offset using the file descriptor size and seek type absolute. You're going to write to the file, and if not append, then you're going to truncate the file descriptor to the size. All right. Now, anywhere that I'm calling simple write, I'm going to need to update it to say whether you append or not. So for example, the data appends, but the structure truncates. Although truncate won't actually do anything. Fuck, I forgot about that. I can just change the buffer size, I guess. Wait, no. This whole thing didn't make any sense. I probably should have checked that the bug that I thought was happening was the one that was actually happening. But when we're reading the file, we're reading only what's currently in the buffer, not the total size of the buffer. So that doesn't make any sense. Anyway, you truncate so you don't append. It's not that many places where I'm calling it sWriteF, so should be able to just very quickly, 8 places total. 3 of them are here, 2 of them are here. You don't append, and you don't append. Okay, but now back to the terminal. I don't think this error is gonna be fixed. Because again, I think the correct size of the file was just what's written in it. Yep, the error is still there. Okay, so it's something else happening. And struct sync, here you are. Okay, and you know the size of the file, so tell me that. No, it is receiving. Oh, I'm actually a little bit dumb here. And in other places too. Yeah, I'm hard coding the size of the file. That doesn't make any sense. When you open the file, I'm hard coding the size that it's gonna give you. Well, at least I made sWriteF make a little bit more sense. That's always nice to have. Boom, there we have it. Did part structure, received command, number 1, name numero uno, type dir, size 6, modified a while ago, and did deserialize. You're still printing logs here, but that's because they're coming from the terminal directly. So those are still printing. In case the terminal has some issues with deserializing data, it should tell us. So if this fails, failed to parse structure. Actually, it is already going to print the error. So we're good. Here we do have to print errors. Invalid structure and invalid data. All right. So I was being a little dumb, but in being a little dumb, I ended up fixing something that didn't really make a lot of sense. srif was just doing whatever. Hi, Peter. Neural networks are not the totality of AI. That's true. But when we talk about AI, we mostly talk about neural networks and LLMs nowadays. All right, so let's see it with proper output. I didn't get rid of some. Hold on, let me get rid of some more lugs. Like this one here. Okay. This should display in raw text. Here we have the data that it displays after that. And the process actually is printing more stuff that we don't actually see because it does not show up in the terminal. So I would say that works. Pretty sure. That seems to work according to me. And kind of the best part about it is that I'm going to be able to move a lot of the functionality of what I've written for the terminal into the shell. And when I do that, I can move it to C. And it's going to be a beautiful thing to see. But it's just copying and pasting code, so I'm not going to do a whole lot of that on stream, most likely. Most likely I'm just going to do it throughout the week. And yeah, all right. So my terminal can now display structured data. But let me do a little bit more of a test. Because I can send you that data, and then I can do another serialized pass with the same data, but let me modify it a little bit so that the teacher doesn't realize that I copied the homework. Modified, we're going to say just now. No, slice literal. Just, not sure why I'm yelling, just now. And that's going to emit the same data but with modified information. Now there is a little bit more behavior that I need to add. The terminal should be able to decide whether to scroll or to override. So, all right, right now it printed twice because data gets okay. That is simply because when we're doing a data sync, we're still reading the full file, so that's wrong. Okay. So I'm going to change that real quick. I do end up needing a data file descriptor because this is a file that we're technically kind of streaming. OpenF S4 data into data file descriptor. Then I'm going to string free S4. Cool. And I realize I don't have a something similar to tell, but smarter, that tells me the new size of the file before I read it. So it would be very useful to have that way. Hold on, let me not delete the entire thing. Um, So I'm gonna need to add that syscall, but I don't have it right now, so we'll have to make do with doing a read into a data buffer that we provide. Now we can use a data buffer for this. Screw it. Another thing I want to add is a to-do buffer map to file functionality, so that a buffer represents a file, so it automatically reads from it, writes to it, keeps itself in sync with it, but it doesn't own the file or anything like that. It just copies its data. I don't know if I'm gonna add that. That is a lot of work, to be fair. But anyway, your data buffer, we're gonna allocate it for the time being, and then we are going to... I can always use the same one, actually. That's fine for now, I think. But what is your problem with that? Ah, I need to cast it, because it's C++. It's a stupid language. Alright, the data file descriptor. No, the data file descriptor. You're going to write into the data buffer. And you're going to write that much, which is the maximum that we can hold. But in reality, you're probably going to write less, so we're keeping track of that. And that should make sure that we only read one piece of data at a time. The repo is public. You should be able to find it if you do that. And it did. Okay. So this time it read the first part of the file, and then when new data became available, it read more parts of the file later. And it's the same file, but it has been updated by the process, so it does that. Cool, what time is it? It's nearly midnight. Okay, the terminal does have a clear command, right? Okay. So I'm gonna very quickly speed run this part, implement the last file that I need to implement for the last kind of behavior that you need, the environment behavior, which is whether you scroll or you wipe. So, to do that, the terminal is going to need to keep track of its current behavior. Environment behavior scroll by default. It's only going to apply to like structured data, right? Then if the current behavior is wipe, then we're just going to clear. Otherwise, we're just going to keep writing to the terminal as usual. We will need, again, a new command to synchronize, which now I'm using escape. I could use something like substitute, or I could use the device control ones. It's not like they're doing anything else. The behavior file descriptor goes into the proc environment behavior, and that is of the size of an environment behavior type behavior. And the default of that is environment behavior scroll. So I need to create this. I got this wrong. It's environment behavior is the name of it. All right, so I need to create the file descriptor. I need to create the string for it. I don't need to open the file. Here, I also don't need to open the file here, but whatever. I could do a read full file of the behavior string. No need to know the size. Well, oh no, if I do a read like that, it's gonna be easier. Then I need to create this environment behavior type. Default scroll. Okay, so if you receive a command that's going to be the behavior sync, then you write it into here with default value being scroll. And if this is different than the current behavior, then you set the current behavior to this thing. All right, so to the environment, that's the wrong file. I need to define this thing as a string, and I'm going to be using device control, which is decimal 17. How does it know whether this is decimal 17 or decimal 1 and then 7? I think it does, but yeah, I'm a little bit scared. Sync is just the environment command behavior sync string. Okay, then static inline void send set environment behavior to. I'm not sure why I'm separating the environment behavior from the environment display, to be honest. But I am, so it's fine. Maybe I'll change it. Your environment behavior will now be writing to behavior. That and that. And then environment behavior sync. And finally, need to create a new file for it. Data signature doesn't really matter in this case, so we're good. Probably better to copy from here. Environment behavior. And you map to the behavior. Does it not have a behavior buffer? It does not have a behavior buffer. You map to this behavior buffer thingy. So you create the behavior buffer if you need to by mapping it to the value of behavior. Type behavior. And then when you resolve, you case environment type structure return proc environment behavior buffer. And that's type behavior. I'm pretty sure I maybe can create this buffer and this buffer directly in here, so at least I don't have to create them every time manually like that. But, all right. If everything is set, then we set the environment structure to that, and we also set the environment behavior to environment behavior wipe. So we should only see the second bit of data, and if I make the process sleep, it should update. But I didn't finish that. The behavior file descriptor is never getting opened. All right, that should be it. That didn't work. Maybe rushing it wasn't such a good idea. Did I actually end up setting up the, yeah, behavior sync? Let me see if that's working. It is receiving a behavior sync. And then tell us what the new current environment behavior is, which, by the way, I'm holding these as kind of like a terminal global values here. But really, the process is setting them, but then the next process shouldn't inherit them. Oh, it's receiving invalid data. I'm not sure why you think you're receiving... Oh, no file for 8 behavior. Okay, so that explains why it's happening. Okay. I forgot to actually declare that file. Oh, Terry Davis jump scare just there. Okay, it is working, but it's saying invalid data. I'm not entirely sure why. Neither is Jester, but we do see that it is working. So, sleep for a second. Wait. Yeah, because it says invalid data. Again, I still don't know why it says that. That worked now. But it did update the value with the thing that I expected it to have. We wait even a little longer. Kinda looks a little weird. But it works. It works. That works. That works. That's pretty cool. Okay. Well, yeah, I feel like I'm starting to open too many files for this shit. So definitely, most likely, will be merging behavior and display into just config, environment configuration. Then you can just hold your own structure for it. I'm not doing it now because it is almost midnight and it would be a bit of a waste of time to just refactor code right now. But finally, the terminal is able to show... Wait, hold on. There is one more tiny thing I want to try. Although I'm not sure I'm going to be able to. Well, yes. I can certainly try. No, okay. I was going to try setting colors for the data, because there is a current color, text, something like that, a text color, just text color, text format. Well, I don't even remember what it is, so... Yeah, the problem is I don't really have a good way to set them right now, and again, I don't like ASCII escape sequences for that. They're not where I want to go with it. Oh my god, what's happening with my hair? They're not the way to go. I find them to be impossible to read. So yeah, next time, impossible to decipher what's going on here. So maybe something like a very basic version of rich text format, just supporting a very small type of subset of it. At least it's a little bit more readable, I think. It's been so long since I've looked at it, not entirely sure, but I do think it would be a better option for text color. And honestly, text formatting shouldn't require a separate file. I do believe that. Just, I don't like the escape sequences themselves. Okay, so I'm done for today. I finally did set up, indeed, even though it doesn't have color, data structures in the terminal. So it's able to display that in an orderly fashion. It should be able to display it in tables, but I also have to decide the layout of the tables. And about that topic, I'm pretty sure I might change my mind. The next thing to do is to finally get to actually structuring this data better, doing text color, doing tables, doing complex operations on the terminal. And to do that, I was yesterday thinking, should I do terminal UIs separate from normal UIs, or should I allow to integrate normal UI into the terminal? And I do think the way I want to go about it is I want to go with terminal UIs because they are different. So I provide more options. You want to do a UI application? You do a UI application. I might even eventually expand this so that a certain section of the terminal, instead of being text, is just UI. And I give you that to draw it to, if you so wish. But not really important right now. We'll see. I would love to have a combination of terminal UI and regular UI and text, and it's getting a little bit of a mess. So yeah, terminal most likely. The next stream, when I actually start doing this, is going to be Friday. 4 days from now. I might change my mind, but I think I want the terminal to just display text, and by choosing what we do with that text, we can do a little bit more extra information, extra UI stuff. Right. So, or I might just do, I have an idea, but I'm going to leave it for Friday. All right. Thank you so much, everybody. I will see you then. And we'll do some terminal UI my own way. We'll see what that looks like. All right. Thank you so much, everybody.